Okay guys, so we are going to do section 3.4. Okay, and 3.4 is the title of it, is proving that lines are parallel. Okay, proving lines are parallel. When I do that symbol, that means parallel. Okay, and before we do that, before we can even get involved in that, we have to review something or go over, probably teach something from chapter 2 that you guys haven't seen before. And it talks about conditional statements, okay? So a conditional statement, now don't get bogged down with the truth or whether the statement is true or false, okay? Because that's not what we're looking for, okay? A conditional statement is one that has an if and a then. If it is sunny, then it is warm. Okay? So that's just an if-then statement. The if part, the part after your if, is called a hypothesis, and the part after the then is called your conclusion. Okay? So I say, if it is sunny, then it is warm. Now, if I wanted to take the converse of that, the converse is when you switch the hypothesis and conclusion. So the if and the then stay frozen there, and you switch the hypothesis and the conclusion. And you say something like, if it is warm, then it is sunny. Okay? I flipped the hypothesis and the conclusion. Again, I don't care if they're true or false. It doesn't matter if they're true or false. Okay? What matters is that you understand the converse is switching your hypothesis and your conclusion. Okay? So another one. Let's say I said this. If x equals 2, then x squared equals 4. Okay? Now, if I wanted to find the converse of that statement, I would switch my hypothesis and my conclusion. If x squared equals 4, then x equals 2. Now, it doesn't matter. It doesn't matter. Like I said, it doesn't matter if they're true or false right now. Okay? This one's true, this one's false. Can anyone tell me why they think that that one would be false? In order to prove a statement is false, you would want to have a counterexample. Okay? And the counterexample here would be, well, x could also be negative 2. Okay, but I'm not worried about true or false right now. I'm not worried about it. Okay? If it is Friday, then I will have pizza. Okay, so I want you guys to pause the video, and I want you to find the converse of that statement. Here's the statement. Here's the converse. Here's the statement. Here's the converse. Here's your statement. I want you guys to go through and find the converse. So I'm hoping you paused the video and we would say something like, if I have pizza, then it is Friday. Okay? There you go. That is your converse. Okay? I usually have pizza on Friday. That's why I came up with that sentence. Okay? I'll think of one more. Let me think here. Let me see. Let me see if I can find something in the book if it has one. Yeah, this is a good one. If an angle measures 125 degrees, then it is an obtuse angle. Okay? Or I could say, then angle 1 is obtuse. That might be better. That might be a better way to say it because it'll work better. Angle 1 is obtuse. So I want you guys to find the converse of that statement. Find the converse of that statement. Pause the video if you have to. Here we go. If, well, that's the conclusion, and this is the hypothesis. So I'm going to say if angle 1 is an obtuse angle, then it measures 125 degrees. Okay? Not a true statement. However, it is the converse. It is the converse. So why do we talk about converse? Well, everything that we learned in section 3.3, we're going to take the converse of it in this section. So you're going to have something like this. The corresponding angle converse. Okay? So let's think about what the corresponding angle theorem was before we used converse. It said something like if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So now I'm going to say if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. Okay? So if you had a figure like this and it told you that that angle is congruent to that angle, then I can say that M is parallel to N. Okay? So kind of shorthand, if two corresponding angles, oh boy, here goes my pen, are congruent, then the lines are parallel. It's kind of like the shorthand version of that. Okay? Now, as we talked about for corresponding angles, as you can imagine, we are going to say alternate interior angle converse. So if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Okay? So if you had a picture like this, and you had this angle congruent to this angle, then you can say that the lines are parallel. So if we can say it for corresponding and alternate interior, you can be sure we can say it for the alternate exterior. Alternate exterior angle theorem. Here we go now. Okay, alternate exterior angle theorem. If two lines are cut by a transversal, so the AEA's, alternate exterior angles, are congruent, then the lines are parallel. Okay? And then the last one, and then we're going to pause the video for a second. I'm going to say consecutive interior angle. Oh, this should be converse up here. not theorem. My mistake. Converse. Converse, the consecutive interior angle converse says if two lines are cut by a transversal, two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. Okay? So for that one, if we had something like this, and they told you that 1 and 2, angle 1 plus angle 2 equals 180, then we can say the lines are parallel. If we had something like this, and they told you that this angle was congruent to this angle, then you can say the lines are parallel. Okay, I'm going to pause the video right here. We're probably about halfway through with this. See that? I gotta put my pizza in. I'm making a pizza, and that's my timer. My oven has preheated. I'm gonna go put that pizza in. I'm gonna come back, and we're gonna look at some more problems in section 3-4.